Welcome back to Physics with Miyoshi, and I'm here with my little pendulum. It's actually a yo-yo, but using it as a pendulum today to talk about, introduce a little bit about simple harmonic motion. So, what does a pendulum have to do with simple harmonic motion? Well, what is simple harmonic motion? It's motion that goes back and forth and back and forth and back and forth. And with simple harmonic motion like this, you notice that at the top of my arc, it's got potential energy, and as it goes through its motion, it gets less potential energy and less potential energy and more kinetic energy. And when it hits the bottom, then it's got all its kinetic energy, and as it goes back up, it loses kinetic energy and gets back potential energy. In this case, gravitational potential energy. And that's what simple harmonic motion does. In its simplest form, it just changes potential energy to kinetic energy and back and forth and back and forth and back and forth again. So, let's look here. We can also do the same kind of thing with a spring, and if we have a horizontal spring, it's got supported by something here, and there's no friction, then we can have simple harmonic motion in horizontal axis. We could also do the same thing with a spring in a vertical axis. And when we look at any kind of simple harmonic motion, we notice that it looks like a sinusoidal type of wave. Matter of fact, you see that as it goes back and forth and back and forth, it would produce a sine type of wave, and that would just be the displacement, just for the displacement. And when we look at that, we can see that the displacement from what we call the equilibrium point, whether that's horizontally or vertically, that's when the string the spring is not stretching or compressing, and that distance from the equilibrium point is what we call the amplitude. So the amplitude of would be the height of my sine wave from its zero or from its equilibrium point, and that would be the maximum displacement it's going to receive, either horizontally or vertically. It doesn't really matter. And in this case, that would be my x. The potential energy of a spring is actually something I'll talk about here. Is just 1/2. Oops, that's a terrible 2. 1/2 kx squared. Would be my potential energy of a spring, of an ideal spring, and that again is just the displacement. So the maximum would be my amplitude. So when it's a, then this is going to be 1/2 k a squared, and that would be the when it's all potential spring energy, and then it's going to get all its kinetic energy here in the middle, and that would be all kinetic energy, which, as we know, is 1/2 mv squared. So if I have a mass connected to that spring of mass m, then I could see that it's going to go back and forth between kinetic energy, 1/2 mv squared, and potential energy, which is 1/2 kx squared. It's just going to keep going back and forth and back and forth. Another thing to note is that something called the period. The period is the time it takes for my whatever is in simple harmonic motion to go back and forth between a starting point and an ending point. So if I was at the bottom, and time it takes to go to the top and then back down again, that's the period. One time is the period. If I was in a horizontal, it'd be the time it takes to go from one end back to the top and then back to the bottom again, or left again. If I'm using a pendulum, like I showed you in the beginning, it'd be the time that goes from the top point to the top and back to the top again on the other side. Or it'd be the time, that's a little bit trickier, if you go up, back, and back down, that would be also the period. So you can take it anywhere from any two different points as long as it's corresponding. So if it's on the sine wave, it could be here, it could be here, but those are all the period. And if I want to look a little bit farther, the frequency is how many times it happens in a second. So the frequency would be 1 over the period. And we'll use all those things later on. So, for a pendulum, the nice thing about harmonic motion for a pendulum, it's all gravitational potential energy, which is just mgh. So here it starts out some height from its equilibrium point. It goes from no kinetic energy at the top to all kinetic energy at the bottom, and then it goes back up to potential energy. And this is very easy to see. It's a nice example. That's why we use pendulums as an example of simple harmonic motion, because it's all potential energy, gravitational potential energy up on top, comes down, and it's all kinetic energy at the bottom, and then it's all potential energy again. And it goes back and forth, swapping between kinetic, and potential energy. Again, it's the same with our spring. It's going back and forth between kinetic and potential, but this time it's potential energy of the spring. In this case, we actually have, in the vertical spring, we actually have gravitational and kinetic, gravitational potential energy and kinetic or spring potential energy and kinetic energy all in there as well. So we'll talk about all that stuff a little bit more as we go along. But remember a few things about simple harmonic motion. That the main thing to remember is that we go back and forth between kinetic and potential energy. So potential energy at the outside in these kind of cases, and kinetic energy in the middle point here, if you will. And remember that it's a sinusoidal type of motion. We should remember the amplitude is the maximum displacement. If it would be the maximum height here in this case, and it would be the maximum height in this case as well. The period is the time it takes to go from corresponding place to corresponding place on our curve, if you will, and the frequency is 1 over our period. So, just a few things about simple harmonic motion and just a little introduction. And remember, anytime you see something going back and forth and back and forth, it's probably not somebody trying to hypnotize you or anything, but it's time to think about simple harmonic motion. So, thanks for tuning in, and hopefully you tune in back in again later for more Physics with Miyoshi.